Right, let's try one more LeetCode problem. So we're dealing with one that I have not attempted before. So we're given, well, actually, it's LeetCode 398, random pick index. We're given an integer array of nums with possible duplicates. Randomly output the index of a given target number. You can assume that the given target number must exist in the array. Implement the solution class. The constructor initializes the object with an array nums. Int pick in target picks a random index I from nums where nums I equals target. If there are multiple valid IDs, then each index should have an equal probability of returning. Constraints, well, we have at least one number. And the target is an integer that actually exists in the array. And there are going to be thousands of calls to be made to the pick function, right? So let's look at an example. So we init it and then we pick a random index where the 3, so it could be one of these 3 indices. We pick a random index where 1 is, so that should be that one. So constructor returns null. Picking for 3 returns the index 4, 0, 1, 2, 3, so 4, so that index. Picking for 1 returns the index 1 because it's the only one. Then picking for 3 again, this time returns the index 2, so that 3. All right, so yeah, so we can deal with some randomness here. Well, how are we going to do this? Well, we'll be giving an array of nums, right? So, and in a pick, we basically have to pick an index from, well, we have to pick an index where nums has the same value at target at that index. So I think a first step could be to just create a hash map where the key is the value of the number. And then we attach maybe a list of all the different indices at which that number might occur. So that's what we could do. Yeah, that's something that we could do. Since apparently nums fits into memory, that's what we can do. And then we just have to use Python's random function to pick a random element from the list of indices. So yeah, so that'll be O of n time and O of n space for the initialization. And then the picking should be constant time. So let's implement that real quick. We do self dot data equals, we're going to have a dictionary, I suppose. And we're going to iterate over all of the values, I and n, in enumerate nums. Right, and then all we have to do, maybe make this a default dict of a list. And we, well, use it from collections. So actually we should probably say from collections import default dict. There you go. In LeetCode, it's probably not necessary, but in other environments, you might have to import it explicitly. So what we now do is we say self.data, or should we say, yeah, we just leave it at data, at index n, appending the value I. So that's all we do here, right? And then when we do the picking, well, we get back the list. So that's self.data at target. And we know that it's guaranteed that target exists in nums. So that means we have an entry in data with the key of target. That's what we have. So now comes the random part. Well, we need to return a random element from that list. We could import from random import randint. I happen to know that this is a function that the Python random package provides us, and it allows us to pick an element between 0 and the end of the range. I think is also inclusive, which is weird because for most Python, like for a range or something, it's actually not inclusive. So what we'll This is just something to remember. So pick equals rand int, and between 0 and length of the list -1, right? Because the last index is the length of the list -1. So then we just return st at pick. So that should be everything. Let's run the test to check our syntax, and it works. And then we click submit. Very nice. So that's that solution. Now there could be a follow-up problem, especially when you're a more senior candidate. Like, how do you do it when your nums array doesn't really fit into memory, right? What do you do then? How can you still like make a random draw? For example, if you had a add self n, and instead of specifying a nums, we just specify capacity here. Capacity. And yeah, well, in that case, how do we deal with that? So now we need to manage, you know, how many elements can fit in there. How would we do that now? So we'd probably have something where we say self dot or maybe like a time to live queue, maybe a deck that points to the elements that were inserted. And once we run over capacity, if over capacity, in that case, you know, we pop the next element from the time to live queue, self.ttl.pop left, something like that. And then we remove the element from the data thing, the index. And the data thing probably also needs to contain dex, right? And well, either that or we have like a heap. You'd also have like a heap where no, heap wouldn't really work. I don't think it would. No, well, it would work, but it's not as effective. So a deck is just O of 1, insert and remove. So that's more effective than using a heap to find the next element to get removed. So, and then we just, here we would just remove e from self.data, right? If over capacity. And here what we do is we add n to self.data, right? So that will be self.data at n, append well, itself, right? So data, we're just adding the target. Oh, we're just adding the value here, right? Really, that's all we have, all we're doing. But we have to remember the index. So we have to keep track of the index, like which element is it? Self.index, if we wanted to. So that would give us, the index would be the position of the number inside the stream that doesn't fit into memory, right? Like maybe a rolling number or version number or whatever. Append, and that will be self.index and self.index. So we want to increase that, etc., etc., etc. And then we remove elements, etc. It's kind of like a priority queue a little bit, except that it's more like a TTL queue, time to live. So we don't have to actually remove elements and reinsert them and all that, all those shenanigans. And then in the pick method, wonder if you can't really do random access in a deck, right? That's not possible. But you could still you could still, well, either you decide that you still yet to create yourself like a maybe a set of indices, and then you can use the rand int again, I guess, or a list of them. Or can you actually pick the nth element from a set? Is that possible without converting that into an array? Not 100% sure, but I know that there are some techniques that allow you to still sample a random how do you say, a normal distribution or random, no, what am I talking about? A sample like from uniformly from a stream of moving data. That's still possible. Yeah, but I'm rambling on. So this would be a follow-up question. Obviously, I'm not able to implement and reason about that completely, but I also want to end this video so it doesn't get too long. So this is maybe left for the viewer as a follow-up question, how to do that. I gave you some ideas. Maybe you have some of your own. And yeah, enjoy.